Question number 1 is, why is the first ionization energy of phosphorus greater than the first ionization energy of silicon? And these are the four options. A is the phosphorus atom has one more proton in its nucleus. B is the atomic radius of phosphorus atom is greater. C is the outer electron in a phosphorus atom is more shielded. And D is the outer electron in a phosphorus atom is paired. So if we talk about silicon and phosphorus, the question states that the phosphorus has a greater ionization energy than that of silicon, right? Because see, what is ionization energy? It is the energy required to remove the loosely held electron from gaseous isolated atom. So if we talk about silicon and phosphorus, silicon belongs to group 14 and phosphorus belongs to group 15. And silicon has an atomic number 14 and the atomic number of phosphorus is 15. If we talk about the valence shell electrons, it is 3s2, 3p2 for silicon and 3s2, 3p3 for phosphorus. And we know as we move from left to right, size decreases and ionization energy increases. So C phosphorus lies after silicon. So as you move from this side, the size decreases. Why size is decreasing? The reason being is that phosphorus has one additional proton. Phosphorus has one additional proton in its nucleus. And electrons are added up in the same shell. See, when we move from silicon to phosphorus, electrons are added up in the same shell, but there is one additional proton in phosphorus which attracts the outer electrons towards itself. That's why phosphorus has smaller size and it has more ionization energy. So if you look at the option, so A is the correct option because phosphorus atom has one more proton in its nucleus. And if you look at the other options, B is the atomic radius of phosphorus atom is greater. So no, atomic radius of phosphorus is smaller than that of silicon. C is the outer electron in phosphorus atom is more shielded, so no. Outer electrons, they lie in the same shell, so they are not more shielded. D is the outer electron in phosphorus atom is paired, so no, this is not the correct reason for the first ionization energy. In fact, the electrons in p orbital, orbital, they are all unpaired. Or you can also say that this subshell is half filled. Since it is half filled, it has higher ionization energy. So basically A is the correct answer. So that's it. Thank you.